Well, welcome back, campers. Let's continue on with this complex number and polar forms stuff. So, because they're numbers, that means you can still do, a lot of stuff with them. So you can multiply, divide, add, subtract, raise them to powers, root them, all that sort of stuff. So let's see just a couple of arithmetic things. So if we have these two complex numbers, if we multiply them together, it's actually a really simple process. What you do is you take your r's and multiply them together. And then multiply it by CIS. And then take your thetas, so theta 1 and theta 2, and don't multiply them, you're going to add them. So for division, it's kind of similar. So you're going to take the r's and you're going to divide. And then for the new angle, it's kind of like logarithms in exponential functions. When you divide, that means you're subtracting. So you're going to take your thetas and you're going to subtract them. And just make sure you're going in the right order. So whichever complex number is on top, its r is also on top, and its theta is the positive one. Whichever is underneath, its r is underneath, and its theta, its angle, is negative. Because they might try to trick you. So like for example 3, what the book tends to do is they want to know z over w a lot, but then every once in a while they'll flip it and they'll say, hey, what's w over z, just to see if you're paying attention. All right, so let's try this one out, the multiplication. So just take the z's, multiply them or the r's, multiply them together. And then take the angles and add them. So if you add these together, get a common denominator, and it comes out as 15 pi over 16. And we're going to leave it like this because we're not using calculators, so that's all you need to do with it. So then when you divide them, take the r's and divide. So the z is on top, so it's r's on top, w's underneath, so put the 2 underneath. And then CIS of, now you take the angles and subtract. Whoops. So 3 pi over 8 minus 9 pi over 16. So if you subtract these, you get a negative 3 pi over 16. Well, we want our theta to be positive. We don't want a negative theta. So if you added 2 pi, that would give you a positive angle. So 29 pi over 16 would be your angle. And again, we can't evaluate that really by hand, so just leave it alone. So that's addition and subtraction. So now let's talk about powers. So powers, it's really, just multiplying something by itself over and over and over again. So we can kind of follow this format. So if you did, z times itself 4 times, you've got 4 r's sitting all the way out in front, but they're all the same. So you just take your r and you're going to raise it to the same power that you're raising your number. And then for the angles, just take whatever angle you start with and multiply it by n. So for example 4, for writing this expression out, we're raising it to the 4th power. So take your r, raise it to the 4th. So root 5 to the 4th. And then times CIS. Take your angle, the 3 pi over 16, and multiply it by the same power. So the power is at 4. So 4 times 3 pi over 16. And then just evaluate from here. So root 5 to the 4th, that's 25. 4 times your fraction, that's 3 pi over 4. And this time it told you to write it in standard form. So we got to keep going. We have to evaluate the cosine and the sine of that angle. So cosine of 3 pi over 4, negative root 2 over 2. Sine of 3 pi over 4 is a positive root 2 over 2. And then multiply the 25 in. So negative 25 root 2 over 2 plus 25i root 2 over 2. Okay, so that's kind of how you do some of the basic arithmetic with these. In the next and final video for this section, we'll look at what happens when you take a complex number and cube root it or fourth root it. So stay tuned.